As of right now, yeah.
Can I put us on here?
I did it to my brother.
Ladies and gentlemen, we have a lot of material to get over here today.
You guys go up.
Guys. As of right now, you know basically two relationships between angles and the arcs that they run into. The first one we talked about was what we called the central angle. That central angle, the angle at the center of the circle, is always equal to the arc that it runs into. So the central angle equals the measure of what we call the intercepted arc, the arc that it hits. The one after we did that was the inscribed angle. The inscribed angle was the angle who had a vertex on the circle. So the inscribed angle was half the measure of the arc that it hits. Now, there are going to be other ways that angles can be formed. You guys all agree that angles are formed by, well, for lack of better terms, lines intersecting one another. Or segments, or however, correct? So what I want you to think of here is, how does he always take all the markers and put them on one side? Well, actually, oh yeah, I did drop 2 out of 4. Never mind. So if we have central angle, and we have inscribed angle. So the central angle is the measure of the arc. The inscribed angle is half the measure of the arc. Now, what I want you to think about is how many places then can two lines intersect in a circle? Not in a circle, but intersect a circle. How many different ways can two lines intersect a circle? Well, if you draw a circle, what's a way that lines could intersect? Going through the circle. Okay, so are you talking about it? Are they in the circle or out the circle or where? In the circle. Okay. You can have ones that are. I'll give you a hint. There's 3 ways. Thanks.
That was slightly worse. That would be slightly more worse.
Fine, Fancy Pants, you do better.
I will. I can't foresee this going wrong.
Yeah, so there. Well, you have to write some both.
I need to see one that would be better. Oh no, the pressure. Like the pressure.
Boom. Bazinga.
Do another one.
No, it's not. It's not too big. I just have to move
It's
this
more
around.
elliptical than it is round.
It was a lot more round than yours was.
True.
You know, all I see with this is this. It's a giant fly coming at you. All right. So let's narrow this down. We'll use the circles that look nice. There are 3 ways that we can do this that we're going to look at today. And I'm going to avoid my names. Multiple names. There's multiple names.
Always like
Grammar police is coming after you.
puts that.
So here's your hint. There are 3 ways that we're looking at this stuff today. And basically it's going to join, it's going to be Outside, inside, or on the circle. They're going to intersect outside the circle, inside the circle, or on the circle. Yes, ma'am. I don't know. Fight over it. Who goes first?
Wait, what? Oh, I was just saying, like, I was like trying to block the building and just staring at me.
Oh,
Ignis, please.
here's what we have. When I'm talking about with angles being formed, when you're talking about two lines intersecting with a circle, they can intersect either outside the circle, inside the circle, or on the circle. Okay? There are a lot of vocabulary terms with all of it that I do not even bother using because it's a waste of time. Basically what I want you to be able to do is this. When two lines intersect on the outside of a circle, it looks like this. I know, right? Here's your angle. The angle is outside the circle. It then has two lines going through the circle. So that angle is formed outside the circle. Yes, Mike? So you can have, like I said, we're going to have three ways of looking at this. Outside, inside, and on. See, it's not as easy as it seems.
My first one was good, and then the rest were crap. Like,
So when you have an angle being formed on the outside of a circle, when you have an angle being formed on the outside of the circle, how many arcs does it run into inside the circle? Two of them. It runs into two different arcs. It runs into an arc here and an arc here. We okay with that? One of the arcs is closer than the other. So we can say one is a close arc and one is a far. A far arc. It's not a fart, it's a far arc. It's not as stinky as it sounds. Okay? So this angle is going to be a combination of what I call the far and the close. So what you have to be able to tell is which one's further away than the other. That's a tall tale for you to do, but I'm sure you can probably figure it out. So here's what happens. Your angle, when you are outside, is always going to be equal to half the far minus the close. Oops. That outside the circle one, the angle will intercept, the angle is created outside the circle. Here, I'll put it on the smartboard so it's easier to see. If I have an angle on the outside, that angle is going to equal half the far minus the close. All right. There's a lot of if we use the actual book terminology for this stuff, it is a giant pain in the rear. So that's why I like to use the words far and close, near, away. All right. So there's your outside. The next one is the inside. And believe it or not, you've actually used this before. Inside. Come on, guys. Inside. When you have two segments that intersect inside a circle, how many different angles are created? Try it again. Two. When two lines intersect, how many angles are created? How many different angles? There's only two different ones, unless it's perpendicular. So what happens here, if you're inside, if that's one angle, doesn't it have another one that's the exact same as it? Yeah, not the adjacent one, it's vertical. The vertical angles would be here and here. We agree on that? So what happens is, if this is your angle here, this angle is looking at this arc. Correct? And yet, that angle, by virtue of its vertical buddy, is also looking at this arc. So when you are inside the circle, you're looking at two arcs. So your inside method is, let me make this out, move this over a little bit. Your angle is going to equal half the sum of the two arcs that it hits. Because that angle, it being the exact same angle because of vertical angles, it could run into two different measured arcs, and that's fine. That's perfectly fine.
Could be x plus x.
No, no, no.
No?
All I'm saying is here, this, just looking at one angle, I just put that one there because it's vertical. This angle looks at this arc,
Yeah.
and by rule of vertical, it's also looking at that arc. This one down here. It's just, you're gonna work with one angle. You're not working with all of them at first.
Okay, so then it would be that arc,
Yep. The angle is going to equal half the sum of the two arcs that it hits. All right. Think of it as an average. All right. It becomes pretty easy when we start putting problems on here about how you're looking at this stuff. It's really, really fast. So your angle.
It looks like some pretty good circles.
There's something. And then the last one was on the circle. So if you have outside, we have inside, and then we have on. I gotta make this one just a little bit smaller so we can see it better. If we are on a circle, this angle is created on the circle because the two lines intersect there. What happened last time you had an angle that was created on the circle? What was that angle called? The angle. We just did all that past 2 days. Inscribed. Inscribed angles were always equal to half the arc they ran into. Inscribed angle was an angle whose vertex was on the circle. Isn't that an angle whose vertex is on the circle? What do you think the rule is? Half of what? Half the arc. That's all it is. It's the same rule as inscribed. So the angle is going to equal half of the arc that it hits. So this angle here runs into this arc here. So that angle will be equal to half of the arc. So you have outside, inside, on. So your angle is half the arc. It's half of that. Okay? If you notice, when we're talking about all the different setups and formulas, if you have outside, you have angle, half, far, and close. One of those things that will always be there is the half. That leaves three things that can interchange, which means algebraically you could have two of them solve for the third, no matter which part it is. When you have inside, same deal. The half doesn't go away, but you have three other parts. You can get two of them, find the third. So a lot of this winds up being really fast 1-2 step equations. Just a matter of labeling which one you're using. Okay? Outside, inside, on. That's all you gotta worry about. All right? Outside, inside, on. So let's look at an example. a 1,000?
1,000, yeah.
Because centi's 100, so milli would be 1,000. I don't know. I'm from the USA. We use what we call the ounce system. There's,
How many ounces are
I have no idea. I don't know what a liter is.
Is there a math teacher?
I don't deal with volumes and liters and stuff. Science. I'm no scientist.
Wait, go back.
No, I know a 2-liter bottle is 64 ounces-ish. So 1 liter is around 32 ounces, maybe? I don't know. There's this great thing called the internet. You can probably look it up. Yeah, I hear it's on computers now. I like how you roll your eyes and download that beyond that. That was very nice. Thank you. All right, so this example here is your angle outside, inside, or on said circle. On. So which of the 3 formulas am I going to use? Outside, inside, or on? On. So here's what I want to do, especially today. It's an on problem, which means angle is half the arc. Well,
114.
what is my angle?
228.
Wrong, that's the arc.
Oh,
It's half of 228.
I don't know why I said 40.
Pretty quick. Your angle is equal to half of the arc that it hits because it is on the circle. Okay? And that's usually the reaction that I get out of most people. They're like, what? But remember, there will be some algebra thrown here, but we start with baby steps. Okay? Let's try another one. No. Wow.
That's me when I'm talking about
You're having nothing but nice to you today.
Like, she told me to break something up to the front at work, but we had a meeting, and she's like,
All right, is this outside, inside, or on?
Inside.
but we're from the school, and she goes, are you still sleeping? I was like, you told me to put this up.
It's an inside angle. Since it's an inside angle, we write down inside.
Yes, there is.
The formula for working with it is angle is half arc plus arc. Well, what are the 2 arcs that it runs into? 89 and 63. So your angle is going to equal half of whatever 63 and 89 is.
That's a lot of work. I forgot my calculator again.
There you go. Remember, when you type this in your calculator, you can't just write 0.5 times 63 and then plus 89. You have to throw parentheses on it, otherwise it would be wrong. Yes, ma'am?
And then and with these 2 angles, they both equal the same
Yep.
thing?
Yeah, and that's what I was about to get at here. Since then, you now, what'll happen though is a lot of times they might not ask just for this angle. They might actually ask for this one. Oops. So that means you find this one at 76, and then that angle would be its supplement at 104. Okay? That happens a lot because it'll use the rules of supplementary angles and things like that to bounce back and forth. Okay? So we've done an on and we've done an inside. Which one do you think might be next? Well, that was adorably wrong. I agree. So in this one, we have an angle that's created, is it outside, inside, or on? It's outside. It's outside the circle. So this being an outside problem, oops. This is an outside problem, means angle is half par minus the close. I'm really hoping that you'll be able to distinguish which angle or which arc is further away from the angle.
I don't know, mine's kind of tricky.
I'm hoping you get that right, because otherwise you deal with negative angles. We don't have negative angles in geometry. We'll have negative angles in algebra too, but not in geometry. Okay? So my angle is half of 78 minus 42. What is half of 36? 18. Not very bad, is it?
No.
Which means that means we get to have more fun with it then.
Oh, no.
For example,
You can tell which one.
ladies and gentlemen, come on. I've got about 5 more to go.
You don't know that shit?
So really, what you're going to want to do basically over and over and over again is just ask yourself the question, is it going to be an outside, inside, or on problem? Outside, inside, or on, depending upon what the diagram looks like, what values you have, and things like that. We don't have to worry about the terminology that they use in the book, that this is a secant tangent problem. Doesn't matter. The angle is created on the outside. That's all we care about. So is this one outside, inside, or on? Outside. So again, what I want to do is write down the quick form of the equation, so that way I don't screw anything up. It's an outside, bless you. Angle is half far minus close. Fill in the blanks. What's your angle? Now, how do you undo multiplying by a half? You multiply by a half, or you multiply by its reciprocal. What's the reciprocal of 1/2? 2. Multiply both sides by 2 to get rid of it. Quick algebra. You double 38 and you get and now you're at what works out to be, technically a 2-step equation. But you can do them both at the same time. I don't want a negative value of x, so how do you move a negative x? You add it to the left. And how do I move the 76 from the right? So if I add x, subtract 76, what do you get? What's up, Norm?
I did it a different way, but I got the same answer.
Did you just double it right away?
Yeah.
That's fine. Because isn't that what I did?
I did like negative x and half.
Yeah, and that's okay. That's fine. Then you did 90 minus negative, or 1/2 negative x, negative half x.
Yeah.
Yeah, that's fine. The only reason I would steer away from that is because a lot of times you deal with more fractions and decimals. It's just not worth it. If you're stuck with the parentheses are both even, go for it. Because what's half of 180? 90. If it was a 2x, what's half of 2? 1. It's quicker. In this case, since I have an even and an odd, or an example I have here in a second, I'll have 2 odd numbers. Just double it. What you did though, fine. No big deal. Just be careful with that negative though. I've known so many times students move stuff around and all of a sudden that negative disappears. Okay. Not bad, is it? Okay. Oh no, I can't tell where these angles are formed. I am so afraid. Please make my brain stop hurting. I was sarcastic.
No, really?
Aiden and I both responded with sarcasm.
I'm so used to it by now. Are these angles created outside, inside, or on the circle?
Inside.
They're inside.
I think she needs to buy it.
So these are inside. So our inside angle is half arc plus arc. Well, what's the angle that we're dealing with?
Why don't you just lick your whole finger?
115. And my two arcs are going to be 105 and x. And see what happens here, Thora? If you did 105, half of that, you get, what, 52 and a half and 0.5x. Just too many decimals to deal with. That's all.
I do that anyway.
If you want, go for it. I'm not going to say no to do that. I'm just saying sometimes it's a little bit more work. That's all. I, on the other hand, like to do the easy stuff because working too hard is just not worth it. But Thora, that's all. Thank you, Thora, for. So now, getting rid of the half. I'm going to multiply everything by 2. So if I double 115, I get 230. And the fraction is gone. And now you're at a one-step equation. What's wrong? So, what's wrong? What? Did you not? Do you want me to write down what I did?
Yes.
I'm just multiplying by the reciprocal of the half. Multiplying both sides by 2. Subtract out the 105. And there's my value of x. Again, when you're inside the circle, the angle is a midpoint. Remember when we did this? 115 is a midpoint. What's the other end point? From 105 to 115, did you go up or down? How many? What's 10 more than 115?
Really?
Shortcut. Works. Do you have to do it that way?
No.
Nope.
That's very rare way to do it.
But a lot of times you might have a little bit more algebra. If you don't, go ahead. All right. This is one of the first ones that I can think of that's still easy enough, but it makes you have to look at it twice to make sure you understand the right way to set it up. Bless you.
Thank you.
So in this case here, is the angle that's created and outside, inside, or on? It's on. So you've got a 96 degrees on the circle, but the arc that I'm looking for is on the other side. So there's a couple of ways to do this. Does everybody agree that 96 has a linear pair? What's the supplementary angle to 96? 84.
84.
84. So that means that's 84 on there. Now is that 84 degrees still on the circle? So that means the angle, since it's on, the angle is half the arc. So 84 is half of what? Well, double it, and you get 168 for x. Or you could have done the other thing. knowing that my angle here of 96 is half of the arc that it runs into, this part here,
Oh,
if I doubled 96, is it 192, I believe? I get 192. Well, then I take 360, subtract the 192, and lo and behold, you still get 168. So there's a couple of different ways of going about it. Sometimes it's easier to go one way or the other. It really depends upon how you want to go for it. Okay? It's a matter of going through. Yes, ma'am.
Now, if you do the supplementary, like
Yeah.
when you get the 84, do you really have to set up the equation, or can you just double it?
That's fine.
You don't really have to.
What I'm getting at, I'm getting you guys accustomed to by writing it out, because when we see stuff that has a little bit more algebra involved with it, it's easier to remember that, okay, I know where I have to put parentheses and stuff, but this one's pretty easy since it's got the two arcs. But when we get into, when I get into one like this one, where I have more than one set of variables, it's a little bit easier. It'll be a little bit easier on your brain if you wrote it out, because then you know where everything goes. It's more of a organizational thing, if that makes sense. Okay. Ooh, excuse me. Bless you. So in this one here, guys, come on. Is this angle created by outside, inside, or on? Inside. So I write it out. What's the angle that we're working with? 38, good. 10x minus 1 and then plus an x. Now I have a little bit more algebra to worry about. I have to combine like terms inside the parentheses to start with. Very good. So 10x minus 1 plus an x gives me 11x. And once again, I want to get rid of that fraction because I don't want to work with decimals or halvesies and stuff like that. In doing so, I multiply both sides by 2, the reciprocal of a half. That's how it undoes itself. So if I double 38, this is the third problem with the 38, isn't it? I have 76 is 11x minus 1. Now I am really afraid of how to solve. I don't know what to do first. Please help me. Add 1. And what's x equal to? It's not that the algebra is going to be difficult. It's sometimes you just have to read it carefully as far as how the setups work. If you keep that straight, you're going to be all right. Last one, and I'll give you some problems.
Wait.
Weighting.
Yeah.
Multiply by 2.
You have to do the other side.
Yeah.
Yeah. Because if you do it to one side, you do it to
Yeah. Okay. Last one. In this one, technically what we have are two tangent segments. Is this an outside, inside, or on? Where's the angle? Outside. This is an outside problem. Angle is half the far minus the close. Well, I know what the angle is. and I know what the close is. What's the far? What's this value going to be?
The 360 minus.
What is it? Right. In this case here, if you have a part of the circle, and that part of the circle is x, how much is left for the rest of the circle? 360 minus the x. So if this part of the arc, let's say for example, was 30 degrees. If that was 30 degrees, then the rest of the circle would have been 330 degrees. How? Well, there's 300, math, so there. So because there's only 360 degrees in the circle, you just subtract it out. And it works the same way with variables. It does not change itself. So my far arc would be 360 minus x. And then I still subtract the close, minus x. Well, what's -1 minus 1?
Wait, oh, so negative
-1 minus 1. -2. This is the example that I would take half of what's in parentheses. The reason I would is because 360 is even, as so is 2. So what's half of 360? And what's half of 2? X. Well, 1, but I could have done it that way. Subtract 45, add x, and again, x is 135. Now, if I multiply both sides by 2, like we have been doing, bless you, you'd get the same idea. I'd get 90 is 360 minus 2x, which meant I would have subtracted 90 and added 2x. And I'm going to get the exact same answer of $1.35. So you get these outside, inside, and ons with a little bit of sprinkling of algebra.
Yeah.
Give me some of these to start. Yeah, need to.
Literally, probably.
Go through 18.
I will learn how
Go through 18 on these. Most of you be able to probably should have room on the worksheet. Otherwise, the last 3 or so, there's a little bit more algebra involved. You might want to do it on a separate sheet.
But no one ever does it.
Sorry, I knew you were still right sometimes. Did you get it? I'll put it back up before.
You were like,